Welcome to the DIY Honda Garage channel. In this presentation, we will examine the Diagnostic Trouble Code, or DTC P0717, which indicates a no-signal issue from the input or Turbine Speed Sensor A in the Honda Fit models from 2015 to 2020. This DTC specifically relates to the continuously variable transmission, or CVT, and highlights an electrical communication issue rather than a mechanical flaw within the transmission itself. The input turbine speed sensor plays a crucial role by providing feedback on the rotational speed of the torque converter turbine, which is essential for optimal transmission performance. This sensor is typically located on the transmission assembly, connected to the powertrain control module, PCM, via specific wiring, making any faults in this circuit critical to vehicle functionality. The detection of this DTC prompts immediate attention to ensure the safety and efficiency of the vehicle's operation. DTC P0717 stands for Input Turbine Speed Sensor A, Circuit No Signal, indicating an electrical fault in the circuit rather than a mechanical problem. The affected component, the Input Turbine Speed Sensor A, is integral to the vehicle's transmission system, as it measures the rotational speed of the torque converter turbine. Located on the transmission assembly, this sensor communicates real-time data to the powertrain control module, or PCM, enabling the transmission to adjust its performance accordingly. A failure in the circuit may prevent proper gear shifts and could lead to further transmission issues. Proper diagnostics are essential, as identifying whether the fault lies within the sensor itself, its connection, or the wiring is crucial for effective repairs. Several causes can lead to DTC P0717. The most common issue is an electrical circuit failure, possibly caused by damaged wiring or connectors that disrupt communication between the input turbine speed sensor and the PCM. Loose or corroded connectors can also result in poor signals being sent to the PCM, which may trigger this error code. In some instances, the sensor itself could be faulty, failing to send any signal at all to the PCM. Additionally, external factors such as environmental wear and tear can contribute to the degradation of the electrical components. Hence, a careful inspection of the wiring and connections is a fundamental step in diagnosing this issue effectively. When DTC P0717 is present, several symptoms may manifest, primarily affecting the vehicle's transmission performance. One of the most noticeable symptoms is a delay in gear shifting, resulting in poor acceleration and overall responsiveness from the drivetrain. You may also experience abnormal engine behavior, such as chain vibrations or high RPMs without appropriate acceleration, often leading to the driver noticing discrepancies in expected vehicle dynamics. Additionally, the vehicle's onboard diagnostics will typically flag the issue, alerting the driver through warning lights on the dashboard. Recognizing these symptoms is crucial for prompt diagnosis, as ignoring them may lead to more severe transmission problems down the line. The first step in the troubleshooting procedure for DTC P0717 involves a series of verification checks. Begin by turning the ignition to the on position without starting the engine. Then, use the Honda Diagnostic System, or HDS, to clear any existing DTCs, setting a fresh baseline for further diagnosis. Subsequently, turn the vehicle off and securely raise it on a lift to allow for safe wheel rotation during testing. Start the engine and disable the Vehicle Stability Assist (VSA) by pressing the VSA off button to avoid interference during subsequent checks. It's important to take the vehicle for a test drive at speeds exceeding 19 miles per hour for at least 30 seconds, after which you should stop the vehicle. Finally, check for any pending or confirmed DTCs using the HDS to assess if DTC P0717 reappears. In this troubleshooting step, you begin by turning the vehicle off to ensure safety while handling electrical components. Next, disconnect the 3-pin connector associated with the torque converter turbine speed sensor to isolate it from the circuit. Once disconnected, switch the vehicle back to the on mode, which powers the electrical system while keeping the engine off. You'll need to measure the voltage between 2 specific test points, one connected to the sensor, number 2, and the other grounded to the body. The expected reading should be around 5 volts. If this voltage is present, it indicates that the circuit on that side is functioning correctly, guiding you to the next step in the troubleshooting process. If not, further investigation into the wiring and connections leading to the sensor is warranted. During this phase of troubleshooting, you will continue to assess the electrical integrity of the circuit, now focusing on the VCC2 line. As before, ensure the vehicle is in on mode with the torque converter turbine speed sensor's connector still disconnected from the circuit. Measure the voltage between test points 1 and 2, with test point 1 connecting to the sensor's terminal number 3 and test point 2 being grounded. You are looking for a similar voltage reading of approximately 5 volts. If you receive this reading, it confirms that the VCC2 wire is intact and functioning as it should. If the reading is not as expected, an open circuit in the VCC2 wire that connects the sensor to the PCM needs to be repaired. Completing this check is essential before moving on to evaluate the performance of the sensor itself. In this STEP's assessment, you are tasked with verifying the operational status of the torque converter turbine speed sensor itself. Again, keep the vehicle in on mode and ensure that the torque converter turbine speed sensor 3P connector remains disconnected. You'll measure the voltage between test points, specifically between terminal number 1 of the connector and terminal number 3. You should expect to observe a reading close to 5 volts. Achieving this voltage indicates that the sensor is functioning properly, and you can begin evaluating potential issues elsewhere in the circuit. However, if the expected voltage is not present, it suggests that the torque converter turbine speed sensor may be faulty and will require replacement to resolve the DTC P0717 issue. This step focuses on examining the NT wire for potential shorts. Begin by turning the vehicle to off mode to safely work with the electrical system. Use the Honda Diagnostic System to jump the SCS SRS control system line, a necessary precaution to ensure safe testing. After you set up the SCS, you will disconnect the PCM connector, specifically labeled as C51P, to isolate it during testing. The next step is to check for continuity between the sensor's terminal number 2 and the body ground. A positive continuity result indicates that there is a short circuit to ground in the NT wire running between the turbine speed sensor and the PCM. If continuity does not exist, it indicates that this wiring is intact, and further checks will be necessary in the following steps to identify other potential failures. In the final step of the troubleshooting process for DTC P0717, you need to perform a continuity check on the NT wire. By ensuring the vehicle remains in off mode, place your focus on the wiring from the torque converter turbine speed sensor to the PCM. It's crucial to have the torque converter turbine speed sensor's connector and the PCM connector C51P both disconnected. Again, conduct a continuity test between the sensor's terminal number 2 and terminal number 33 of the PCM connector. A positive continuity reading indicates that the NT wire is operationally sound. If continuity is confirmed and the PCM software is outdated, The solution may involve updating the PCM or substituting it with a known good unit to determine if it resolves the DTC P0717. Otherwise, if there is no continuity, it suggests there is an open circuit in the NT wire, demanding repairs before the issue can be fully resolved. After completing all necessary repairs associated with DTC P0717, it is imperative to execute a final verification to ensure the issue has been resolved. Begin by using the HDS to clear any stored DTCs, including P0717, from the system. Following this, take the vehicle for a test drive to assess its performance under normal driving conditions and monitor for any recurrence of issues related to the turbine speed sensor. Pay close attention to gear shifts and general vehicle responsiveness. If no new DTCs reappear during or after this test drive, and the vehicle operates as expected, it is a strong indication that the repair was successful. Documenting these steps ensures a comprehensive understanding of the issue and substantiates the repair progress for future reference. Preventive maintenance is essential to avoid recurrence of DTC P0717 in Honda Fit models. Regularly inspecting the wiring associated with the input turbine speed sensor can help identify early signs of wear or damage, thus preventing future electrical failures. Additionally, checking all related connectors for corrosion or looseness can significantly impact the signal integrity and overall electrical communication between the sensor and the PCM. It is equally important to keep the vehicle's software updated to the latest version, as system updates often include critical improvements that can enhance the performance and reliability of the transmission system. By following these preventive maintenance suggestions, you can help ensure the longevity and optimal function of the vehicle's transmission system. In conclusion, understanding DTC P0717 and its implications is vital for ensuring the proper function of the Honda Fit's transmission system from 2015 to 2020. This diagnostic trouble code signifies an electrical problem with the input turbine speed sensor A circuit, which cannot be attributed to mechanical faults in the transmission itself. Prompt diagnostics are essential to identify if the issue lies within the wiring, connectors, or the sensor itself. Following a structured troubleshooting approach, as outlined, can lead to effective repairs and restore optimal vehicle performance. Finally, committing to regular maintenance practices not only aids in preventing future issues, but also fosters confidence in the long-term reliability of the vehicle. Please like and subscribe to the channel. See you next time.